Welcome to Mr. Leman's Knowledge Explosion. The purpose of today's video's lesson is to introduce you to a process called inductive reasoning. Now, I would wager many of you use inductive reasoning on a daily basis without formally acknowledging it. Shame on you. This powerful thinking process consists of three parts. First, looking for patterns. Second, making a conjecture. And then third, the most important part, verifying that conjecture. Let's look at an example. In this example, we can see that the change from 1 to 4 could have been made by adding 3, or multiplying by 4, or any combination to get to 4. However, the change from 4 to 16 can also be explained by multiplying by 4, as can the change from going from 16 to 64. So a pattern of multiplying by 4 emerges and allows me to make a conjecture, an educated guess, that the next number in the sequence will be 64 times 4, or 256, and that most likely the next number after that will be 256 times 4 again, which equals 1024. This is inductive reasoning. Let's pause the video here and see if you can make a conjecture about the next two numbers in this next sequence. Hopefully you paused and noticed the pattern of the increasing the previous number by 3 more than the prior increase. For example, negative 5 plus 3 was negative 2, but negative 2 plus 3 plus another 3 equals 4, and that 4 plus 3 plus 3 plus another 3 equals 13, so 13 plus 3 plus 3 plus 3 plus 3, or 12, would equal 25, and then 25 plus 15 equals 40. This is inductive reasoning. I notice a pattern, and then I make a conjecture. My conjecture is an unproven guess based on my observations. Let's look at another example. Here's another pattern I witnessed this summer while driving through Illinois. Every road I traveled appeared to have some form of construction slowing me down. After several frustrating hours in the car, I arrived at the following conjecture. Now comes the most important part that most people ignore. You must verify your conjecture as true or false. You may have witnessed some of this construction yourself, but the street where you live is not under construction, or the street down the block, or down in Jonesboro where your grandma lives. By finding examples directly conflicting my conjecture, you have proven it false. We call these conflicting examples counterexamples. So here's a main idea. To prove a conjecture false, you need only one, I repeat, only one example that shows the conjecture false, also known as a counterexample. But to prove a conjecture true, you must prove that the conjecture is true in all cases. This is much more difficult to do, and we will explore this idea through proofs in later units of study. So in summary, inductive reasoning is a three-part process. 1. Look for a pattern. 2. Make a conjecture, or an unproven statement based upon your observations. And then 3. Attempt to verify that conjecture, saying it's either true or false. But remember, to show your conjecture false, you need only one counterexample. But to show that conjecture is true, you must show that all of the cases are true. Thanks for watching this episode of Mr. Leman's Knowledge Explosion. You should now work on your Lesson 1 practice about patterns and inductive reasonings. Good luck, and see me if you have any questions.